Hey, what's going on, guys? Let's do this problem right here. This question is asking a galvanic cell is made using 0.25 molar ZnSO4 and an unknown amount of CuSO4. The cell potential is 1.05 volts at 50 degrees Celsius. What is the concentration of CuSO4 in the cathode compartment? And the B part is asking how many grams of CuSO4 are dissolved if the cathode compartment contains 250 milliliters of solution, right? So here they are asking for the concentration of CuSO4. Now let's see how we can figure it out. So whenever we have concentration, that is only related to this equation, that is Q is equivalent to product over reactants. So product over reactants. Now let's look at the products right here. We have Cn2 plus product. This one is not going to come because this is in solid form. So whenever we have solid and liquid form, it's not going to be included in this equation. Now here we have Cn2 plus and Cu2 plus is in aqueous form. So these are the two things that's going to come in the equation, right? So let's put the equation first. Q is equivalent to product over reactant. Product is Cn2 plus, and since we don't have any coefficient in front, we just have to put 1 to the power. And in the reactant side we have Cu2 plus, so that's going to be in the bottom, Cu2 plus, and that's also power 1. And here they are asking for the concentration of CuSO4, so we are trying to find Cu2 plus, and if we calculate this one, that's going to be the concentration of CuSO4. Now let's rearrange this equation. Cu2 plus is going to be equivalent to Zn2 plus, right, over Q. Now we have Zn2 plus concentration, that is ZnSO4 concentration, that is 0.25. Now let's put that one as a note. So here we have Zn2 plus concentration, that is equivalent to 0.25 mole per liter. Now here the thing is we have to find Q in order to solve this problem, because without Q we cannot find Cu2 plus. Now to find the Q we have to use this equation, one of these equations. The first one is E is equal to E naught minus RT over NF ln Q. So this is one of the equation, and another equation available, that is E is equal to E naught minus 0.0591 n log Q. So these are the two equations we use in these kind of problems. But for the second equation we have to have the temperature, that is 298 Kelvin. Now let's check whether we get 298 Kelvin right here. Now here we have 50 degrees Celsius, right? Now to convert this one into Kelvin we have to add 273 to that. So T is going to be equivalent to 50 plus 273, and if you add them together, that's going to give you 323 Kelvin. And this is not equivalent to 298 Kelvin, right? So we cannot use the second equation. So this equation cannot be used. So we have to use this one. Now let's see how we can. So here we are trying to find Q. Now let's see whether we have all the information available. E is non-standard cell potential, that is provided right here, and standard cell potential, that is provided right here, and R is energy constant, that's 8.33145. we know that, and temperature we found out. Number of electron, we have to find out that one. To find out number of electron, we take the oxidation half and reduction half and see what is the electron number we use to balance that one. So here if I take oxidation half for this reaction, we are going to have Cn. Cn is the oxidation half. So this is going to be Cn giving us Zn2, plus 2, and to balance this one we have to put 2 electrons, right? Because we have 2 plus, so 2 minus, that will balance this one. Now let's look at the reduction half. That's going to be Cu plus 2. Again we have to put 2 electrons to balance this one, and in the other side we are going to have Cu. And if you see that to balance this one, we use 2 electrons, right? So n is going to be n is the number of electron, that's going to be equivalent to 2. Now we have n value, F is Faraday's constant. Now we can solve for the Q value. Now let's go ahead and solve it. Now before we solve this one, we have to rearrange this one. Now let's take everything other side. So here we are going to have E minus E naught is equivalent to negative RT over NF lambda Q, right? Now if I take this NF to the other side, that's going to be E minus E naught times NF is equivalent to negative RT lambda Q. And if I want to have lambda Q alone, I have to move this negative RT to the other side. So we are going to have negative E minus E naught NF over RT lambda Q, right? And to get rid of this lambda, but we take E power. If I take E power both sides, E power E and lambda cancels, so we have Q. So we will have Q is equivalent to E power negative RT, this is actually E or E minus E naught on top. So we are going to have E minus E naught NF over RT, and that's going to be equal to Q. Now let's plug the values. E power negative. Now let's see what we have for E minus E naught. E is non-standard cell potential, that is 1.05, right? So 1.05 minus 1.1, and then N is number of electrons that we found out, that is 2. Then Faraday's constant, that's going to be 96485, and then in the denominator we have R value, that is 8.3145, and the temperature we calculated 323. And if you calculate this value, if you plug this in calculator, you should get 36.33. Now we have the Q value. Q is equal to 36.33. Now we can solve for this Cu2 plus. Cu2 plus is basically we found out Saturn 2 plus over Q. Now Zn2 plus we found out that we know that it's provided in the question, 0.25 mole per liter, and then we have to divide this one by this Q value to calculate this concentration of Cu2 plus. Now let's go ahead and do that. We found out Q value is 36.33, and if you divide this one, you should get 0.00688 mole per liter, right? Let's write this one clearly, 0.00688 mole per liter. Now we have this, so this is the first question, A part. Now let's look at the B part. B part is asking how many grams of CuSO4 dissolved if the cathode compartment contains 250 milliliters of solution. Now we have done the A part, now let's find the B part. So we need some space right here. Let's get rid of these things, right? Okay, now let's do the B part. B part is asking how many grams of CuSO4. So here they are asking for the mass. We have this one available. This is concentration. Now let's put that one right here. This is actually mole per liter, 0. So let's write this information first. That is, if Cu2 plus concentration is 0.00688 molar, this one also same value, that is CuSO4 concentration also 0.00688 molar. Now we are going to use this information to calculate the mass. let's plug the informations. First we have 0.00688. Molar is actually mole per liter. So this is mole, this many moles per 1 liter, right? Now here they have given 250 milliliter. Now this is helpful because we can cancel this liter, and here this is in milliliter, right? To convert this one into liter, we have to divide this by 1000, and if you divide this one in by 1000, that's going to give you 0.25 liter, right? So from this one we can cancel this liter, but finally we want the gram, right? And if you think about this, here if I multiply this one by molar mass of this one, that will cancel the mole, and finally we will end up with grams, numbers of grams. Now let's figure out the molar mass of CuSO4. And if you calculate this one, CuSO4, actually Cu is going to be 63.55 and S is 32.07, and we have 4 oxygen, so 4 times 16, and if you calculate the total molar mass, that's going to give you 159.62 molar mass. This is gram per mole, right? And if I plug this one right here, 150, so we have to arrange this one in such a way that will cancel this mole, and finally we will get gram. So we have to put this gram on top and mole in the bottom, right? So this is going to be 159.62 gram over 1 mole. And now let's cancel the units. Liter cancels, mole cancels, finally we will end up with gram. And if you calculate this one, that's going to give you 0.2745 grams of CuSO4, and that's going to be the final answer. I hope you guys find this video helpful. See you next time.